Alexa, what is marginal cost?
In economics, marginal cost is the change in the opportunity cost that arises when the quantity produced is incremented by 1 unit. That is, it is the cost of producing one.
Okay, she knows. All right, so we can figure this out, right? What is marginal cost? What is marginal revenue? It is actually just an instance of the derivative. When we say marginal, we mean one derivative. Okay? All right, so here's some concepts you need to know. Okay, profit is revenue minus cost, and revenue is price per item times items sold. Or, for short, we say P is equal to R minus C. Sometimes in your economics textbooks, my other students have told me you will be using a pi. And that makes more sense than the way our textbook does it, but we'll stick with the textbook. I sometimes make a curvy lowercase p. The problem is this p can sometimes look like this p, so you got to be careful, okay? But they're two different p's. All right, another concept. Revenue at 0 equals what? So maybe you should pause and think about this. All right, so what is the revenue when you sell 0 items? It has to be 0. Yeah, of course. Okay, because you always make $0 when you sell 0 items regardless of the price. Okay? So let's compare these two situations. In one case, we're saying that there's a constant price regardless of the number sold. Okay, this would be for small quantities. Let's say a Girl Scout troop. And maybe I'm wrong. Maybe this isn't the way it goes. So for example, in Boy Scouts, if you sell enough popcorn, they give you back more of the profit. But let's assume for the moment that the Girl Scout troop is going to make a certain revenue as a certain fixed ratio of how much they sell. So maybe they get to keep 30% of the profits for what they sell, and so that's a fixed ratio, and then that's going to be the same throughout the entire. Now it doesn't matter if you sell 10 or 100, you're still going to get 30% back. So that's just going to be a straight line. Okay. Now what's this situation? This is the situation where they basically tell you the more the price has to drop in order to make items sell. So price drops to make more sales. And here price is constant. And this is going to quickly get us into this idea of elasticity of demand, but we will do that later in the semester. Okay? But these are the two basic scenarios. The one in which the more you sell, the more you make, and there's no change. You're still, well, let's think of it this way. If you eventually go way out, this curve is going to end up leveling out. But for the amount of cookies the girls are selling, it looks like a straight line. So that's essentially what it's saying. But this is saying if instead of selling the number of Girl Scout cookies we see, if they made them available all the time, and they actually came to your door with an infinite supply each time they came, we probably wouldn't be as interested. But because they know to do it just once a year, and they're actually kind of hard to find, so then they keep the demand nice and healthy. Okay. Another way you can think of it is price is price, which we use a little p for, is approximately equal to revenue per additional item. So this is like an item price, or price for one item. So the derivative of revenue is kind of like price. Okay, so it's kind of true, at least when you're really, really close to 0 on this curve. Okay, you can also think of this. What's the difference between thinking of price as a function of quantity and quantity is a function of price? Okay? On the one hand, you say, okay, by changing price, we control the number we sell. Okay? What's the other thing? In this situation, we are probably in a market competing with other people. So price determined by all the items for sale, not just ours, right? So in this case, we have to live with whatever price the market sets. So here we set market sets the price, and we have to determine whether or not we want to participate. Like my friend just started a business selling flowers, but she's not the only one selling flowers, so she has to enter the market, and she already knows that there's a certain price structure out there, like what the customers will pay. And so the price the customers would pay depends on the quantity available right now. Versus if you have a patent on a very popular toy, let's say, maybe when Rubik's Cubes first came out. Okay, you own patent on a popular toy, then by changing the price, you can control the number you sell. Okay, so you can think of these concepts either way. Okay, so here's a diagram that the book normally draws, so you'll see this in your textbook. How to represent, visualize profit from a cost and revenue curve, both of them. Okay, so how to visualize profit. Profit is revenue minus cost. And so when revenue is higher than cost, we have yummy profit. Yay, profit. Okay? And unfortunately, if the cost is higher than the revenue, we have a loss in this situation. Okay? And again, we have a loss over here. There we go. I hope you can see the difference between those two colors. Okay, so what kind of situation could cause this? Okay, so what situation will cause this kind of weird looking curve? This is a really dramatic typical example, but I want you to sort of see this. This is a very common book diagram. Down here, it looks like a line, and we have fixed costs. So really what should happen is this should come up maybe here, okay? Fixed costs, equipment. So it doesn't necessarily look like a line. I lied to you. So what I meant to do was maybe make the curve kind of more like, let me try to fix that. Okay, that's a little better. So the fact that we start above this is because we have fixed costs. Okay, then what's happening in this zone? In this zone we have more like economies of scale. So in this zone we're trying to, we've now paid off our equipment and it's getting cheaper for us to produce. Like we have all our startup costs taken care of. So maybe we have a flower business and we have a whole bunch of extra flowers sitting around and they're going to go bad and we don't have enough customers. So we just make a whole bunch of bouquets and sell them off real cheap because they're going to go bad anyway. So we may as well just make them and sell them off. Okay. I guess that was a bad example, but because I'm confusing the fact that like when I'm buying the flowers as a customer versus when I'm buying them as like somebody who's making the bouquets. It's a different process. So the point is you're getting economies of scale in here. All right. Now we don't like this. This is bad for the business. And why do we not like it? What's causing it? So sometimes you hit your sweet spot and then things get more difficult again. So one thing you might end up with is you might have overgrown the size of your factory. It doesn't have to be a physical factory. Okay, so you may have overgrown the size of your factory, and for example, things are getting more expensive because maybe you need to do overtime pay. All right, so maybe it was cheaper down below because you were paying people their normal hourly rate, but if you want to push production up higher, then you're going to end up with more cost, because more cost per item, because now you're paying time and a half. Or maybe you've hired all the people who are willing to work at cheap, and now you have to hire people, pay more people to get more people on your staff. Or maybe because of that you have to raise everybody's rates. There's a whole bunch of things that can happen, but there can be a sweet spot where you're getting a lot of profit and the cost is pretty low, but suddenly your costs start going up and it's not necessarily proportional to the number of things you're selling. Okay, so what is marginal analysis? Okay, marginal analysis is we're going to be taking derivatives. So if I say MC, it means C prime. If I say MR, it means R prime. And if I say MP, and this is where your textbook in your economics class might use a pi, is a pi prime. So if price is revenue minus cost, maybe you won't be so surprised to find out derivative of price is derivative of revenue minus derivative of cost. This is a really cool fact that you can take derivatives over subtraction, and that's pretty cool. But now that you know that, then you can simplify it. Okay, so you can take the derivative in economics by putting a prime on or putting an M in front. You're just going to read it marginal cost, marginal revenue, marginal price, and you only do that for the first derivative. You don't do like MMP or anything like that. Okay. Okay, I'm like managing school closing notices on my phone while I'm making this video, so sorry about that. Okay, marginal means for one more. Presumably it comes from the idea that if you've got a margin on your paper, you're putting little jottings over here and you're doing like piecewise subtraction, pair by pair subtraction on a column somewhere. So that's what at least that's what I imagine when I think of the word marginal, but it means for one more. Okay, so CQ might be cost of Q flights, right? Then C of 101 minus C of 100 is approximately equal to C prime of 100. We just took the derivative, but because we're dividing by 1, right, so 101 minus 100 is 1. So since these are just neighbors, then we don't have to do like divide by, right? So just to be formal, so we're dividing by 1, but we don't need to write that out, okay? So the cost of the 101st flight. Okay, let me draw a picture. Okay, so we haven't done this formally, but I just want to show you a picture, okay? So if I want to just, yeah, I'm having trouble with this, hold on. This guy will be like a secant line. We call this a secant line, which is the line between 2 points. So so 100 comma C of 100 and 101 comma C of 101. Okay, so that would be a secant line. which is not quite the same as what we would get if we just have a tangent line. And that's that ruler on the bus. Ruler on top of the bus at 100. So the tangent line at 100, or if you prefer 100, C100. Either way, you're saying the same line. Okay? So the secant line is going to be slightly different from the tangent line, but it's a good approximation, especially when these 2 points are really, really close together. Okay, so here's an example. You may have a table of some sort and you're trying to find out where is marginal cost the smallest. Well, you can calculate that marginal cost by calculating the derivative like we did in our warm-up. But because the step sizes are all equal, and the question didn't ask us what is the marginal cost, it just says when is it the smallest, then you can just look at the steps. Let me do these subtractions. Okay, so these are just subtractions of these 2 consecutive values of C, and you say, aha, right here, that's the smallest one. So, like, actually, what you're going to get, if it said estimate what the marginal cost is when it is minimized, if I said that, then I would have to actually go ahead and calculate it. So I'd say 75 divided by 500, so marginal cost at, let's say 2,500 is approximately equal to this value. Okay, as you can see, that's 0.15. Okay, so that would be how you would actually do it. But if it's only saying when is it the smallest, you would say somewhere in this vicinity it's going to be smallest. Okay? Okay, so here's a question that the book likes to ask. Which is greater, the marginal quantity at Q1 or at the marginal revenue at Q1? Okay, so the marginal cost at Q1 is that slope. And the marginal revenue at Q1 is this other slope. So which one is greater? So if you put the bus on that curve, which curve is steeper? So the cost curve at Q1, the revenue is, the marginal revenue is greater. Okay? But what about at Q2? That's the same question at Q2. Is the marginal cost, oh, here's a different question. Which is greater, the marginal cost at Q2 or the marginal revenue at Q2? And actually the answer is still the same, right? Because the slope of the marginal revenue is actually the same. It's a constant either way. So it doesn't matter the fact that, for example, revenue minus cost, we have profit here and we have loss over here, right? We have revenue minus cost is positive here and negative here. But even though we flipped from having profit to loss, the relationship between marginal revenue and marginal cost did not actually change. Okay, so that's just something to be careful of. I'm pretty sure you have a homework question like that. Okay, here's a typical homework or exam question. So let's say you have a production cost, and we know that at 1,000 item level, at 1,000 items, it costs $25 per additional item. But our fixed costs and other variable costs bring us to a point of $5,000 when we're at the 1,000 item level. So how much would we save by just not producing that 1,000th item? We only do 999. Well, we're going to get to subtract 25 whole whopping dollars. We're not going to notice that. But we're just doing these numbers, right? What about if we go the other direction? Well, we're just not going to notice the $25 in either case, but that's what we would do. Now the question is, what if we want to produce 100 extra items? Well, 100 extra items is going to be 100 extra items. We're going to have the $5,000 already, plus 100 of those marginal costs, and 7,500 is our answer. But this is maybe not as accurate. So you have to really be, can't spell accurate. You have to be really aware of the situation you're working in, because it seems kind of suspicious that you're going to raise your production by a whole 10% and you're going to still be on that same curve. Well, maybe you are, but if you know enough about your industry, maybe that's a perfectly reasonable assumption. But just because you can estimate really close to 1,000, you can just go plus and minus one item. You may or may not be able to say plus or minus another 1,000 or plus or minus another 100. So you have to be aware of your industry. But mathematically, this is what the model says you do, and so this is the standard model. This is how you would answer the textbook question. Whether or not that works in reality, you have to figure that out when you get there. Okay, so I'm going to give you a couple exercises to do. You try. Okay, and then you'll pause and do, I'll pause to write them and you pause to do them. How's that? Okay, so here is your exercise, and you pause and do them. Alright, so hopefully you were at least able to get the first one is 4348. You simply, it's a 4300 plus 2 times 24 gives you that answer, right? The other one is a little trickier, but what do? The derivative of profit is the derivative of revenue minus the derivative of cost, and what we want to know is the profit from item 51. So it's just 35 minus 24, which is equal to $11 or whatever units you have. Okay? Alright, so yeah, there you go. Okay, so here's your next question. You try this, think about this, and come back with your answer. Alright, so should we produce the next item? Well, the derivative of profit is the derivative of revenue minus the derivative of cost, the derivative of revenue, and the derivative of cost. So what does this mean? Okay, this is a bad thing to produce, right? So it means we spend 38, let's put units, $38 to make item number 101, but we get $35 more in revenue because of it. So we're actually losing money. It doesn't mean that we necessarily sell that specific item for $35. It might mean that we've changed the supply-demand curve sufficiently that we lower all the prices slightly or something like that. But you could think of it just on a micro scale. You can think of it as being the cost for that item and the revenue for that item. Okay, so we'll not sell that item, not produce it. Okay. Okay, so here we've got a cost, and we should. Not the best picture, but I think you get it. So should we increase the production when Q is equal to 1, 2, or 3? So what do you think? One thing to notice is that right here we have no profit. We also have no profit down here, but that no profit we kind of expected because we were recovering our fixed costs, and so that was okay. So in between, these two no profit zones, we have to figure out what went wrong, right? So we had started to have a little bit of profit at Q1, and then at Q2 we had some profit, and eventually we ate up all our profit because we didn't stop soon enough. So the question is, how do you know when this is not a good deal anymore? And so what you're looking at mathematically with this model is you're looking for when the slope of the revenue and the slope of the cost are roughly the same. So we should probably stop here, and we should keep producing here at Q1, and then you went too far if you went to Q3. Okay? So think about this. Here you've already recouped your costs, and here you've got some profit going on. Profit, profit, profit. Your profit is maximized right here because the slope of this line and the slope of this line are the same. But because now the bottom slope is starting to curve up, then the distance between the revenue and the cost curve is getting smaller, and that means your profit is getting smaller. Okay, we're essentially going to zoom in on these three situations. I want to kind of show you, first of all, I'm going to zoom in on this situation here. Okay, so zooming in on that, you have a situation where you have revenue is higher than cost, but the thing you're realizing is that the cost function is not as steep. Okay, the cost function, so let's exaggerate that even more, the cost function is not very steep. So that means revenue is climbing faster than cost, so this is a good thing, right? And so then I'm going to move my zoom into the next part of the diagram. Right here, my zoom in is going to say, okay, here's my revenue and my cost, and they're roughly the same slope. So it's okay if I stop anywhere in here because the profit is the distance between them. And so anywhere in here, it doesn't make much difference. Maybe you're putting forth more effort, takes more time, but whatever, it's fine. You've got the same profit, right? And then if you see what's happening over here in this zone, then revenue is still the same, but now cost, oh my gosh, like cost is like growing way higher than the revenue function. So there's the cost down there. And so the cost is now trying to eat into your revenue. Okay, so you want to maximize the profit right here where these guys are parallel, then you stop right there. Okay, and hopefully you got some of that. I realize hearing me online is not quite the same, and so what's going to happen is on Friday you'll come back with your questions and we will continue the material then. Have a good snow day, or half a snow day.